good afternoon. Everybody, thank you for joining us. I know there's a few empty seats, so even if you're a little bit tired, come in and sit down, and we'll talk about some SATCOM. I'm Sarah Cleveland. I work for Extra Hop. I am a retired 06 from the Air Force, so don't get upset with me. I know there's a lot of green in this building. And then I'm being joined today with our Senior Solutions Engineer, Mike Guyton, right here. So in true military fashion, when you give a slideshow, you have to give them a slide first that tells you what you're going to talk about, right? Isn't that what you, LT, isn't that what you learned in school? Like you have to give them a slide. So this is what we're going to talk about. So we're going to talk about current challenges with SATCOM, meaning specifically traffic, performance. You know, you get out into the desert and like you have no idea why it doesn't work. So, and then we're going to talk about reclaiming that bandwidth for high-value missions, because it never fails. You have a mission that needs to take off and get going, or you're in the middle of a mission, and everything just goes down, and you have no idea. And then we're going to talk about a case study, and this is pretty current. This has to do with our product and a ISP provider, but it has to do with the Ukraine. So it's a very current. And LT, I'm sorry, I'm singling you out because you're right here. So you got to be my support person. Every colonel needs a lieutenant, just letting you know that. Okay, so we're going to do a case study. So let's get going. Current challenges with SATCOM availability. So SATCOM availability, it's hard to troubleshoot. You get into the middle of nowhere, you sit down, you set up your Hawkeye, and it doesn't work. You filled out the SAR-GAR correctly. You're like, it should be here, and it doesn't work. It's difficult to troubleshoot. So it's also a finite resource. So when you fill out that SAR-GAR, it's sort of a boilerplate SAR that, you know, for that type of mission. But however, your mission might require more data than that standard SAR. So you need to be able to utilize every bit of bandwidth that you got. So that's the key. One of the keys to availability is being efficient use of that bandwidth. The lack of visibility into the network traffic is another issue, because generally speaking, when you sit down with your satellite link, you don't have any idea what the traffic is that's clogging up your network, why the performance has declined, and or why you don't have any performance at all. So it becomes very, very difficult. It's like chasing ghosts in the night. So SATCOM outages, again, they're hard to troubleshoot. You got your link, you got your equipment. It could be data, it could be terrestrial connections, it could be anything. So it's one of those things that if you can eliminate some of that problem-some connections, you're going to have a better time managing that data availability. So nearing the limits of efficiencies. Again, it goes back to that satellite access request that you get given to put in. You only get X amount of bandwidth. And if your mission nears that effective availability, you're going to have some problems when you really don't want to be having problems, because people depend on those comms. Okay, so that's some of the challenges in a nutshell. I'm sure you have all experienced similar challenges with your SATCOM when you sit down and hook it up at your bare base. So reclaiming that bandwidth for mission availability, this is where Extra Hop comes into play. Visibility. Extra Hop gives you that bandwidth optimization that gives you visibility to every single endpoint. So if you're seeing things on there as an endpoint that you don't know what it is or you don't want it, you can then act on that and prioritize the data that's flowing over your network. So knowing what's on your network is that key event for prioritizing data. So you're on mission, and all of a sudden you see a lot of data moving from one server to a workstation that isn't a workstation that's being used for mission. You can now go and locate that computer. It might be in a tent, streaming Netflix, and you can act on it, so that you have that bandwidth available for what you actually need it for. So that visibility into the usage history and traffic trends will let you manage that better. So say there was an event on mission, the link goes down. You don't have time to address it at that moment, but you can go back later and figure out why that happened, what endpoint was it going to, how much data was it, etc. So the current example in the Ukraine is a little bit even more complicated because of the cyber environment. As you know, the Russians are doing a lot of cyber activity the Russians are doing a lot of cyber activity on the Ukrainian forces. That said, they discovered that about 25% of that bandwidth was being used as malware. And so that bandwidth was not available for mission. Because of ExtraHop, they were able to identify that, address that additional bandwidth usage, and regain that back. Now, I know we talk a lot in industry about money, and in the military, money is not as important as mission and people, but that money is already spent by the military. So now you can use that money that's already spent on mission, rather than combating malware or extreme streaming of services that aren't contributory to your current mission. So that will then give you the visibility to gain back that stolen bandwidth. So if you want to hear more about that technically, so JP over here is our he's a sales rep, but he's a sales rep plus, because he's an engineer, and he can talk the packets, he can talk the Wireshark data with you as well. So, he's so much more than just that. So let's talk about that case study. This is probably the thing that you're going to find most interesting. Reclaiming that satellite bandwidth via the network visibility. This is with our current customer over in the Ukraine. So as you can see, they were having issues for performance. They put ExtraHop on that link, and they were able then to suss out what that extra bandwidth was going toward. And then they could then act on eliminating that bandwidth and repurposing it for what it was purchased for. So they were able to reclaim that bandwidth from that malware traffic, which is good for all kinds of reasons. And then currently, the detection that ExtraHop is providing to them has 5 billion events on that network every day that are being detected and can be stopped. So that is one of the really great things about this product, is it can stop that malware, stop events before they happen, keep your bandwidth where it needs to be, which is on mission, and keep your folks communicating. So how do we do that? That's probably one of the things you want to know, is how does this make us different than maybe other people that say they do these things? First of all, we're battle proven in a current conflict. Secondly, I have Mike Guyton here, who is our solutions engineer, and he's going to talk to us a little bit about the typical ExtraHop enterprise deployment.
Hopefully everybody can hear me. First, I want to point out, my slides weren't on the agenda, right? Obviously, I'm prior enlisted. I didn't get to go to that officer training that she did. So, what I'm going to do for the next couple of slides, won't take long, is I'm going to talk about how ExtraHop is deployed a little bit, how we receive the data that we need to provide the information you're looking for, and what we're doing with it, really. So ExtraHop in itself is an appliance. There are multiple appliances that work here. You'll see the first one here is called the EDA, or the sensor. This is the main appliance. This is what you're going to feed us that raw packet traffic to. This could be provided by a span or a tap aggregator or something like that. And then what we do is we'll pass it off for longer storage, if you will, to the EXA, as well as the ETA, which I get in, on the next slide here. Does that all kind of make sense so far? Hopefully, everybody? All right. I don't know how to use a Mac. Bad engineer. Hang on. All right. So once we receive those packets, we're going to do a couple different things with those metrics, right? So those raw packets are coming in. think of the first initial scrape of that data as really metadata that's providing maybe the overall big picture of what's going on within your network, whether it's network related, performance related, security related, things like that, okay? Then what we do is we basically logify that data into transactional data, which is what we call our record store. And what we're doing there is basically kind of laying out the different conversations that are happening between your networks east and west, right? And then the third data up there, what we're doing is taking it, you'll see this a lot lately, there's been some mandates out there around storing raw packets. We have the ability to store those raw packets as well. That's really the only 2 slides that I had. I'm going to be in the back here in a few minutes. If you guys want to talk more technical, or I'll be at the booth if you have more questions. Appreciate it.
So if there's any questions, we'll field questions if you'd like. I think we have 5 minutes if anybody would like to ask questions. Otherwise, we'll be up here. You can ask us up here. Otherwise, we're at booth 01 upstairs, next to, I think, if you come out of the ballroom, we're right there in the alleyway by the coffee stand. So thank you for everybody for coming. Really, really appreciate it. And you have a great AFCEA day.